Number 73 asks us to find the minimum radius of a circle such that the centripetal acceleration at the lowest point does not exceed 6 g's for a jet that's moving at a speed of 1300 kilometers per hour at that lowest point. We could start out by converting that 1300 kilometers per hour of a tangential velocity into meters per second, as seen on the left bottom part of the screen. And we could also draw the free body diagram, which is seen on the upper left part. We could set up our centripetal force equation because we know the net force, or normal force minus weight, is equal to the centripetal force. We also know that the number of g's plus 1 is going to equal the normal force divided by 9.8 times the mass, which is seen in the middle of the screen. If we solve both those equations for the normal force and substitute in, we can have the 9.8 times the mass times the quantity g's plus 1 is going to be greater than or equal to the mass times the tangential velocity squared divided by r plus 9.m, as seen on the right. If we continue to substitute in the terms we know, we can eventually solve out for the minimum r radius value, which is 2,218 meters. For part B, we have to find the effective weight of a 78 kilogram pilot when he is at the bottom of the circle. This is pretty simple because we just use the equation that we used before in the last part, where g's plus 1 is going to equal the normal force plus 9.8 m. The normal force is his relative weight. So if we draw the free body diagram, we could see at the bottom of the circle the normal force pointing up and the weight pointing down. If we solve the g's, which in this case is a maximum of 6 in, and the mass, which is 78 kilograms, we could simply solve out through some basic algebra and see that his effective weight is 5,350 newtons. In part C, we also have to find his effective weight when he's at the top of the circle now. So you can draw this free body diagram with both the normal force and weight pointing downwards. His mass is still 78 kilograms. The only difference now is instead of using g's plus 1 in our equation, we're using g's minus 1. Once again, if you substitute everything in, it's just some basic algebra, and you see that his effective weight is 3,822 newtons.